Okay, mind blowing. We are talking about secrecy of the universe. Actually, We started this discussion where the how a geostationary satellite, if this is the Earth, if this is the Earth, and this part is a geostationary satellite, and this part it is facing. Now, when Earth is moving like this, geostationary satellite will face this only, always, always. If it rotates like this, then geostationary satellite will be here. If it comes here, then geostationary satellite will be here. If it comes here, then geostationary satellite will be here. If it comes here, then geostationary satellite will be here. So we are actually trying to calculate the distance of geostationary satellite from the Earth through the energy principle. What the formula we use, the energy concept, that is our concept, and it is not available in any of the book. Okay, how geostationary satellite distance is measured from the Earth? That is measured through centripetal force and centrifugal force. But our all the calculation happens through Sir Einstein's formula, that is energy concept. Okay, then we found that the geostationary satellite distance from the Earth is nothing but if any item is moving, it generates energy. If geostationary satellite is moving at velocity v, then it is generating energy as mv square, mass into velocity square. That means energy it is generating. That energy is used to nullify the energy Earth is investing to pull it. So Earth is investing to pull it is mass into acceleration. Okay, whatever the acceleration Earth is generating multiplied by this mass, that is the force into dr. Dr is the calculus distance formula, and finally we came to a formula called gmm, but gmm by g, I'm sorry, gmm. G is the gravitational constant, m is the mass of the Earth, and another m is mass of this, by r. That is the energy Earth is investing to pull it to itself. And when it is moving like this, it is generating energy as mv square. So mv square equal to gmm by r. M and m gone, and v equal to gm by r square root. That is the velocity. If we try to find the radius, if we try to find the radius, then velocity, linear velocity, I can convert it into angular velocity. Linear velocity is angular velocity into distance. Then v equal to omega r. So m omega square r square equal to mm gone, omega square into r square. Omega is angular velocity equal to gm by r square. So r to the power 3 equal to gm by omega square. R equal to gm by omega square root, where omega is angular velocity of this satellite, and angular velocity is same as the spin Earth is rotating. Earth is rotating 2 pi angle in 24 hours. So angular velocity is 2 pi by 24 hours. Okay, then we calculated that radius equal to g, that is gravitational constant, into m, mass of the Earth, divided by r, divided by r. I'm sorry, divided by omega square. Omega is angular velocity, that is 2 pi by 24 hour whole square. 24 someone can convert at 24 into 36 into 36 seconds. So 2 pi by 24 into 36 into 36, I'm sorry, 2 pi by 24 into 60 whole square. Settle down, it becomes around 44,000 kilometers. 44,000 kilometers from the center of the Earth, geostationary satellite moves. Then we calculated the velocity of the geostationary satellite. Then v equal to square root of gmm by r, and we came to know it is 3 kilometers per second. Now, then we calculated the velocity of the moon, which is at 380,000 kilometers away from the Earth radius, from the Earth, 380,000 kilometers. It is at 44,000 kilometers. Then we came to know velocity equal to square root of gmm by r. means velocity is inversely proportional to square root of radius. Inversely proportional to the velocity is inversely proportional to square root of radius, or velocity is proportional to 1 by square root of radius. In that sense, if this is 44,000, then if I see the from the earth's surface, then it is around 38,000 or 37,000. That square root will come as 6. Whereas from the surface of the earth, moon is 380,000 kilometers from the surface of the earth, not from the center of the earth, from the surface of the earth, 380,000 kilometers. 380,000 kilometers. 380 square root comes at around 19, because 20 square, 400 square root will come as 20. So difference between 6 and 19 is 3 times. Means if the geostationary satellite moves at 3 km per hour, in that sense, moon should rotate at 1 kilometer per hour. This is where we started. We were not knowing what is the actual speed of the moon. Then I saw the book and I found that indeed the velocity of the moon is 1 kilometer per square. Now, anyway, with that, now anyone can calculate the Earth speed when we know GMM. G is the gravitational constant, 6 into 6, 7 into 10 to the power minus 10 to the power minus 11, and M is the mass of the sun. 1 point, I believe 1.3 into 10 to the power 26 or something kilogram is the mass of the sun, divided by r, whole square root will give the velocity of the earth, and velocity of the earth is 30 kilometer per second. Earth rotates around sun at 30 kilometer per second. In 1 second, 30 kilometer earth moves. Now earth is around 15 crore kilometer from the sun, 150 million kilometer. Mars is around 22.8 crore kilometer, around 1.5 times than the earth. So if that is the case, then someone can find the square root of 15 crore. What is the square root of 15 crore? It will come as more or less 3.7, 3.8. What is the square root of 22.8? Then it will come more or less, I believe, 4.8, 4.8 or something like that. Okay, that is. So what is the difference between 4.8 and 3.8? If someone divide it, that much speed the Mars will carry. 3.8 by 4.8 into 3. If I say this as 4 and 5 for simplicity, then it will be 4 into 3. Okay, 4 by 5 into 3. 12 by, it will be 12 by 5. 12 by 5. Then it will be around 24 kilometer per second. Actually, the Mars speed is 24 kilometer per second. Actually, it is like that. Now, if that is the concept, then anyone can find distance with the speed of any planet or any satellite, that is like Mars has Phobos, Deimos and Phobos. They are at certain height from the Mars. At what speed the Phobos is rotating around the Mars and Deimos is rotating around the Mars? Anyone can calculate very quickly. MB square equal to GMM by R. MM gone, V square equal to GM by R. V equal to Gm by R square root, where G is the gravitational force and M is the entity around which someone is rotating. Whoever is rotating, that entity mass does not come into the picture in the calculation of velocity. If moon is rotating around Earth, then Earth mass will come in the calculation, not the moon mass. Moon mass is negligible. Anyway, so this is the idea. Actually, we started and we came to this conclusion. Someone can try. Anyway, I have some data and that can be verified. Okay, why I brought this discussion, that is not the main reason. The main reason is what about sun speed? At what speed sun is rotating around the black hole Sagittarius, that is at the center of Milky Way? Why this question is? The question is, this is because the Sagittarius is a black hole. Black hole means a star whose all the fuel is burnt, like sun has hydrogen, and hydrogen is converting into helium, and sun is releasing energy, light energy, and that's all. One day will come when all the fuel of the sun will be completely exhausted. In that sense, sun will start shrinking. Like that, there would be some very big star, and fuel got over exhausted, and that star shrunk to a point that is called black hole. Means it is very small. Its effect is very high. Okay, in the effect of the black hole, if light also comes, it will attract it. That much powerful it is. Sagittarius A, that is the black hole at the center of Milky Way, but actual size of black hole is very small, very tiny. If someone believe me or not, 1 inch of black hole, if hole is 1 inch wider, this is consider this is black hole. The weight of the black hole is 1 inch black hole is 2.8 times more than Earth. Can someone believe it? Earth weight is 5.57 into 10 to the power 24 kilogram. That is the weight of the Earth. Okay, 1 inch of black hole is 2.8 times more heavier than Earth. That is the condensed the black hole is, because fuel is burnt and it shrunk like this, but the effect of this black hole is very big, whatever it is, whatever it is. Okay, the concept is black hole cannot be very heavy because fuel is burnt. This is my conception is, if that is the case, then black hole fuel is burnt and black hole is a kind of a shrunk item, then how it is making everyone rotate like around him, because energy is very high, but the velocity at which sun is rotating around the black hole, that velocity equal to gravitational constant into mass of the black hole divided by the distance at which sun is from the black hole, square root. Mass, if I consider less, because fuel is burnt, right? Mass is less, then but it has to show very heavy mass. The mass of the Sagittarius A is considered as 8.54 into 10 to the power 36 kilogram, where mass of the sun is 1.989 into 10 to the power 30 kilogram. That is 10 to the power 36 kilogram, 10 to the power 6 times more than the earth, whereas Sagittarius is very small. Its effect, the effect of the Sagittarius is very big. Okay, so that is, I believe, the effect of the Sagittarius is 23 million 23 million kilometer is the diameter of Sagittarius. That much the is affected. If anything comes inside that, it will attract it. Where the diameter of the sun is 1.3 million kilometer, and the diameter of Sagittarius, that is the black hole, it is 23 million. Sun is 1.3 million kilometer. Okay, what I am trying to show is mass is not necessarily what you weigh on the weighing machine. Okay, Sagittarius actual mass, the small dwarf star, would be less, but the effect it is showing, the energy what it is showing, mass, the virtual mass. This is the concept that we are bringing. The virtual mass that Sagittarius is showing any moment is very high because of the energy. Einstein formula is energy equal to mass into velocity square. Okay, so if someone has very high energy, very high energy, and velocity is less, in that sense his mass will be very high. Not required that mass will be like a solid rock only. It will be virtual mass, apparent mass it will show. That is the matter of research of this discussion that we are talking now. So the black hole, the physical mass what it is showing may be very small, but the apparent mass it is showing to the sun, because sun is rotating, and the velocity what sun is gaining is the apparent mass or the virtual mass that it is showing with the formula of E equal to mc square, because E is very high. The energy of the black hole is very high. In that sense, the apparent mass that it will show to the sun is very high. Sun is thinking that there is a very heavy item it kept at the center. That's it what sun is thinking. And it is rotating at a particular speed, thinking about that much mass. But actually mass is very less. And these are the secrecy of the universe. If you see the sun, the center of the sun is not that very hot. The center of the sun is cool, means it's not very hot. And there are cooler points in the sun. There are many black spots inside the sun. And one spot, there are many spots inside the sun, they are bigger than Earth, black spots. They are called cool point. If someone goes inside the black spot, it will be refrigerator. It is very cool. Inside the sun, there are many spots. They are black, means it is very cold. Okay, but at the corona of the sun, that is near the outer surface of the sun, it is very, very hot all of a sudden. Okay, inside the sun, it is not that hot, but all of a sudden, corona becomes very hot. And then at the immediately after the sun surface, it is very, very hot. It comes in million degree Celsius, something like that. But inside, black spots are refrigerator that are very cool, very cold. Anyway, I'll read out some of the data that I have. Anyway, distance from the sun. Mercury has distance of 50 million kilometer from the sun, means 5 crore kilometer. 50 million means 5 crore kilometer. Earth is 15 crore, three times. And the speed of the Mercury is 47.87 kilometer per second, very high speed. Venus is Venus is 108 million kilometer, around 11 crore kilometer from the sun, and its speed is 37 kilometer per second. Earth is 150 million, 15 crore kilometer from the sun, and its speed is 30 kilometer per second. Mars is 228 million kilometer, means around 22.8 crore kilometer from the sun, and its speed is Mars speed is 24 kilometer per second. Jupiter is 778 million kilometer, speed is 13 kilometer per second. Then Saturn is 1.4 billion kilometer and its speed is 9.7 kilometer per second. It is decreasing. Uranus is 2.9 billion kilometer from the sun and its speed is 6.8 kilometer per second. Neptune is 4.5 billion kilometer from the sun and its speed is 5.43 kilometer per second. More you go distance, speed will decrease irrespective of the size of the planet. Jupiter is very big, doesn't matter. If near to Jupiter, if there is any asteroid is there, it is also rotating around the sun, then their both speed will be same, irrespective of the size of the planet that is rotating around the sun. So that is the concept that we are pursuing. Anyway, Earth we have read. Now, if we see the Mars, then Mars we have talked its orbit. It makes a orbit around the sun in 687 days and 24 hours 37 minutes. It spin on its own axis. 24.1 kilometer per second is the speed of the Mars orbital speed, and 86 kilometer per hour is spin speed, axial speed. Okay, and then it has Phobos and Deimos. There are two satellites around the Mars. Phobos is at Phobos is at 13. Okay, Phobos it Phobos lies at, I believe, 1 second. So okay, Phobos is at 6,000 kilometer from the Mars. 6,000 kilometer from the Mars Phobos, and its speed is 2.13 kilometer per second. 2 kilometer per second. Okay, and then Deimos is at 23,000 kilometer from the Mars. Phobos is at 6,000 kilometer and Deimos is at 23,000 kilometer. Phobos speed is 2.13 kilometer per second and Deimos, which is at higher distance, is 1.33 kilometer per second. Someone can calculate with the formula. Anyway, that is the scenario. There are many more data towards it, so we will not go for that. Anyway, what about sun? Sun rotates around the around in the Milky Way around the Sagittarius black hole, and in that sense, sun is around 225 million light year. Light takes whatever distance it travel in 1 year, that is light year. 225 million light year it is away from the center of the Milky Way. So in that sense, whatever, but its speed will matter depending upon the distance and mass of the apparent mass of the Milky Way, of the black hole center. Sun rotates at 230 kilometers per second. Sun along with all the planets, it rotates at 230 kilometers per second. Aeroplane aeroplane moves at 300 meter per second. 300 meter per second. Sun rotates at 230 kilometer per second. If I think that how much at what speed I am rotating around the center of Milky Way, then it is 230 kilometer per second. If sun stops any moment, then I will hit the wall at 230 kilometer per second. Okay, that is the speed of the sun. Okay, sun rotates on its own axis and sun is a gas, so full sun does not rotate in the same angular speed. So center of the sun at the equator, sun rotates in 25 days, one full rotation, where at the north pole, south pole, sun takes 35 days to rotate, make one axis. Sun axial speed on its own axis when it rotates, I believe it would be at the equator 7,189 km per hour. Earth axial speed is 1,670 km per hour. Sun axial speed is 7,189 km per hour. That is the linear velocity, not the angular velocity. Okay, that is the science of the sun. Okay, there are many more data I have. There is the sun, the kind of the time sun makes the orbit, that is called galactic orbit. So these are the concept. There are many things I have written, not required. Okay, so there are two things I wanted to convey. One is how to calculate the velocity of any planet at what speed it is running. Second thing is apparent mass. If this is not required that mass of any item should be very high, main thing that is required is energy. How much energy it contains. If energy content is very high, then it will show a kind of apparent mass or something that is called pseudo mass to the world. Okay, that is the concept of energy. As good as like a snake may be very timid and very less energy, less weight. A snake has very less weight. It is a lightweight. But like cobra, when it shows like this, then many people who are at 10-meter distance also they will fall. Okay, as good it is very heavy at that moment, and then very heavy mass came at that moment and people fall. This is called apparent mass. Energy is converted into a pseudo mass at that moment. This is what black hole is doing, because that much mass probably in a in a physical manner. If there is a gas, then again it is a physical only. That much mass in a physical manner may not be possible. So that is apparent mass. Someone can think about it more because you won't find in the book time frame, in the book arena. But whatever we are talking, this is called God arena. God arena is completely different than human arena. Human jet plane will run at some speed, but anyway, normal aeroplane that is considered as the in day-to-day life. Jet plane are not in the day-to-day life, only during the war time. Otherwise, normal plane in day-to-day life 300 meter per second. Sun is, I believe, 240 kilometer per second. This is sun. The think about the black hole when it is rotating around the the local group, what would be the speed of the black hole? This is called God arena. That is very, very giant and very, very powerful.